All right, moving right along. Here's problem number 3 from the 4-3 notes. Again, when you have some type of repeated multiplication or some type of powering going on, look for a pattern in your table. If there's a vertical pattern, the number that's doing all the changing, so if it's multiplying by the same number over and over and over again, put that number as your base, and then x will be your exponent. If you see some type of horizontal change or horizontal pattern, x will be your base, and then the number doing all the work will be your exponent. All right, so let's take a look here. Let's find a rule for this situation right here. So let's take a look. Here's all this smart person stuff, blah, 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 blah. Look for a pattern, all right? So let's see here, 2, 4, 8, 16. Oh, come on, are you kidding me? Vertical pattern, looks like you're taking everything times 2. Okay, so if I have a vertical pattern of times 2, that means the number doing all the work will be my base and x will be my exponents. Here's my equation. I'm gonna go ahead and say that y equals 2 to the x power. How do I know? Well, here's x value of 5. I need 5 2's to do this. I need 4 2's. I need 3 2's. I need 2 2's. I need 1 2. There you go. It says it so right there. There it is. Okay. Hey, I got the same thing as the book. Weird. Now look at the got-it question. The got-it question kind of flips it. Similar pattern, just a little bit different. Okay. Look for a vertical pattern. Do you see one? No. 1, 4, 9, 16, 25. 3, then 5, then what? There's no pattern going on here. So no pattern. Look at it this way. Come on. You don't even need to try that hard. How do you go from 1 to 1? Now, there's a bazillion formulas that'll turn 1 into 1. So we're looking at 2, 3, 4, and 5. Let's see, how can I go from 2 to 4? I can double it, I can square it. How do I go from 3 to 9? I can triple it, or square it. Take it times itself. Times itself, times itself. So x squared. There you go. Perfect example of the two items, okay? If you're doubling going straight down, repeated multiplication of 2 to the x power. If you are powering the number itself or using the number twice, using it times itself, horizontal change, then you're going to have 2 for your exponent and x will be your base. Okay, I have a few more examples of this. Okay, so here I've got 3 tables here. I'm going to go ahead and see if I can figure out what the rule is for these. All right, so let's look at the first one. I start at 0 and 0. Ooh, okay, then I've got 2, then I've got 8, then I've got 18, then I've got 32. I really don't see, I can take that times 4, but then yeah, I really don't see a vertical pattern right there. Let's see if I can find a horizontal pattern, okay? Let's see here, 0 to 0, there's way too many things that map 0 and 0. 1 to 2, let's see, I could double it, I could square it, and then add 1 maybe, I don't know, I could square it, then double it. There's lots of things I could do here, so yeah, not sure yet. How do we go from 2 to 8? Well, I could take it times 4, I could square it and get 4, then double it. Maybe I could do that. Ooh, there we go. Square it, 4, double it, 8. Square it, 9, double it, 18. Square it, 16. Oh, there we go. So square it and double it. So there's my pattern right there. I'm going to square these numbers and then I'm going to double it. So start with, the best thing about Desmos is that you can kind of guess and check and you can manipulate your equations live to map the x values onto the y values. So let's double check, make sure it works. 0 squared times 2, still 0. 1 squared times 2 is 2. 2 squared times 2 is 8. Squared times 2, squared, yep. Okay, we're good to go. Sweet, moving on. Next one, look for a vertical pattern. Oh, come on, man. Times 4, this is easy. Okay, so I'm basically taking it times 4. How many 4s do I need? Well, that's what the x values tell me. So this is going to be y equals 4 to the x power. 4 to the 0 is 1. 4 to the 1 is 4. 4 to the 2 is 16. 4 to the 3, 4 to the 4, end of story. And then just for old-fashioned sake, let's see what's going on here. Oh, I see the pattern. I'm adding 2. Ooh, that's how I'm changing. Now, where did I start? Right there. Remember, the x value, when that's 0, that tells you where to start. Okay, so I'm starting there and I'm changing by 2. So my equation is going to be y equals 2x, how I'm changing, plus where I started. There you go. Making rules all over the place, my friends. We'll see you in class. Bye-bye.